Okay, so number one, where's the horizontal asymptote for that function? Well, what's the degree of the numerator? 2. The degree of the denominator? 6. If the degree of the numerator is less than the degree of the denominator, horizontal asymptote at y equals 0. Remember, this is the equation of a horizontal line. Don't just write 0. Y equals 0. The equation of a line. 2. What's the degree of the numerator? 4. The degree of the denominator? 2. So the question is, where's the horizontal asymptote? Well, the degree of the numerator is greater than the degree of the denominator. We have an oblique asymptote. It's not horizontal. That's the answer. The horizontal asymptote doesn't exist. It's oblique. It's not horizontal. Now, if you wanted to find the oblique asymptote, you would have to do long division, but they were trying to not make you do that here, because the question specifically asked for, where's the horizontal asymptote?
Are you going to throw that? Is that all right, or is that mandatory trick?
2. Can you write an equation of a rational function g where the limit as x approaches infinity of g of x is 4/5?
Y equals 4x plus 5 over 5x plus something. Yeah. That'll work.
It's unconventional with the something, but that's fine. That'll work.
I put plus 3, actually.
Oh. That's a little more conventional. Or you don't even need it.
Yeah. 4x over 5.
Or you don't need this.
Oh, wow.
Or they could be both to the... What are they talking about here? They're talking about
That rule.
as x gets very large, that's a horizontal asymptote, what we're leveling off at. So if I need the horizontal asymptote to be at 4/5, it needs to be the leading coefficient over the leading coefficient. It could be something like, because that reduces to be. There's all kinds of different ways you could get there. Here's the one that they wrote. Why take all that time? I don't know. Because they can. Right? Don't have to. Yeah, that's the main point.
Literally. You got the whole squad left. I am the whole squad.
Questions on 2.
Wait.
3. A rare species of insect was discovered in the Amazon rainforest. To protect the species from extinction, entomologists, I nailed it twice today, transferred a certain number of insects to a protected area. The population P of the new colony, T days after the transfer, is given by the function P of T equals 50 plus 25T over 2 plus 0.001T. A, what's the y-intercept? How'd you find that? Okay, how could you do it without a calculator? Because this is one I could give you without a calculator. Yes. Where do y-intercepts happen? When the x value is 0. Think about the y-axis. The y-axis has an x value of 0. Plug in 0 for x. So if you plug in 0 for t, you're left with 50 over 2. 50 over 2 is 25. That's the y-intercept. It's just like with the polynomials, it's the constants. Give the y-intercept. And so we found the y-intercept is 25. Give me what this means in the context of the problem.
There were 25 insects when they started.
That's it. T is 0. So at the beginning of their time, when they first brought insects in, there were 25 of them. Right? You're just giving context to the situation. B, what's the limit as t approaches infinity of P of t? Again, that's a fancy way to ask what? Where's the horizontal asymptote?
Is it a big number?
It's bigger.
25,000? No, 2,500?
2,500.
25 over 20.
Leading coefficient divided by leading coefficient. 25 over 0.01, which is 2,500. Give me what this means in terms of the context of the problem.
Operation is a peak value of 2,500.
So peak is a funny way to say that. You're not wrong, but that's like when you say it that way, you make me think it's going to peak and come down. But a horizontal asymptote's not about a peak and coming back down. That's a better way to say it. There's a max value of 2,500, or the way they say it is the population will stabilize at 2,500. Right? It's not going to ever get above that. You see why peak's not great? I mean, we see I don't know how they would count that, but this is the better way to phrase that with a asymptote. And then 4, the graph of f of x has the same mean behavior as which of those? So we haven't talked about this explicitly, but we did talk about what wins at its extreme values. So in behavior is extreme values. Which term in the numerator wins at extreme values? The highest powered term. What term in the denominator wins at extreme values? The highest powered term. So what's the in behavior going to look like? It's going to be whatever fraction you get when you divide the highest powered term of the numerator by the highest powered term of the denominator.
Andrew guessed wrong.
What did he guess?
He guessed C.
So he was dividing the 4 by -2, but he didn't divide the x's. Right? So like I said, we didn't talk about that one exactly, but it does make sense that at the end behavior, at its extreme values, the highest powered term wins. So when I look, the degree of the numerator is greater than the degree of the denominator. So I know it's going to be an oblique asymptote. And so I need to do long division to find what that oblique asymptote is. So we actually practiced a long division problem yesterday, which was cool. Because you set me up perfectly. If you don't remember how to do long division, I'm going to do it up here on the board. We always want the first term to cancel. And so they need to completely match. So I had an x squared. I want it to be 2x cubed. X squared times what is 2x cubed? That's going to be 2x to the first. So I need to distribute that to all of these terms. So 2x times x squared is 2x cubed. 2x times negative x is negative 2x squared. 2x times negative 20 is negative 40x. And then to do division, we subtract these values. So I'm changing every sign. What used to be positive becomes negative. What used to be negative becomes positive. The first two terms cancel, which they should do every time. If they don't, you messed up. 5x squared plus 2x squared is 7x squared. Negative x plus 40x is positive 39x. Bring down the negative 6. Now I have an x squared. I want a 7x squared. X squared times what is 7x squared? 7. Then distribute. 7 times x squared is 7x squared. 7 times negative x is negative 7x. 7 times negative 20 is negative 140. And then we subtract. So we change every sign. The first term cancels. If it doesn't, you messed up. 39x plus 7x is 46x. Negative 6 plus 140 is positive 134. Now I have an x squared. I want it to become an x to the first. When I decrease in power, I know I'm finished. So this is the remainder for the for this case where I'm looking for oblique asymptotes, we don't use the remainder. This is just garbage. And so this is where the oblique asymptote occurs, at y equals 2x plus 7. If you want to, you could check it graphically. Right? That's one way you could check. Does that make sense on a graph? So let me do that very quickly. I'm trying to give you all the information I can. Let's see, I need to get my piece of paper so I can know what the function is. So I've got y equals, let's see, I should have a 2x to the third plus 5x squared minus x minus 6 over x squared minus x minus 20. So there's that graph. And then I found the oblique asymptote to be at 2x plus 7. You see how as x gets bigger and bigger and smaller, we get closer to this value, this asymptote? And now the second question is, do they ever intersect? Well, looking at the graph, it looks like they do. Right? You see where the red line crosses the blue line? So you could find it graphically. If you guys remember how to do that, second calc, you can go to intersect. And I want to find where the blue line intersects the red line, somewhere around there. Okay, that's where it says the intersection is. That's one way. Or we could do it algebraically. So let's find where the intersection might be algebraically. I'm looking for... Did you just mess up and do something different?
No, like the graph you had up there looked different.
Okay, yep, I can show you why. I can show you why. You guys just have to talk to me. I forget. I get carried away, remember? I just love math. I can't stop talking about it. Speak up. So zoom 6, this is what your graph would look like. Right? If I'm in standard zoom. I need to see more of this. I don't even see end behavior here. So I can click zoom, and then 3 means zoom out. So you can either scroll down, I just click 3, and then you have to click enter to actually do the zoom out. Thank you for stopping me. Anything else on this? If your graph still didn't look like that, then you probably typed it in wrong, and we can figure that out. Oh, this is not going to work, is it? Nope. Okay, so if I go to the other page, I'm wanting to know, where does the oblique asymptote y equals 2x plus 7 intersect the graph, which was 2x cubed plus 5x squared minus x minus 6 over x squared minus x minus 20. This may not have been a good idea. So if I'm looking for where these two intersect, I want to set them equal to each other. So I'm going to erase this and say, I want to know, where does the graph intersect this oblique asymptote? I can put it over 1. No, can't. This is not going to be pretty. Cross multiply. This is probably one you can't do algebraically. Then I have to distribute. Let's just see what happens. I'm just curious. Slide over. Slide over. Okay. The 1 needs to go up there. No, go up there. There we go. 2x times x squared is 2x cubed. 2x times negative x is negative 2x squared. 2x times negative 20 is negative 40x plus 7x squared minus 7x minus 140. Grouping like terms, 2x cubed and 2x cubed is going to cancel. I move that over, that becomes a 7x squared. I move that over, that's going to become a, well, no, nope, okay, hold on. Ooh, interesting. Okay, so if I move that over, that becomes a 7x squared, but then if I move this over there with it, that's a negative 7x squared. That term's gone. So I'm done with these. And then these combine to be negative 47x. Move negative 47 over x. It becomes positive 46. Sorry, I'm just trying to see if this works. 46x, move the negative 6 over, it becomes positive. So that's going to be negative 136. Are you following? I'm just doing algebra, getting x's on one side and everything that's not x to the other side. Divide by 46. I'm just curious. Somebody have a calculator. We do that division. What's negative 136 divided by 46? I think 2.957. That wasn't exactly the answer, was it? It's negative.
It's got more numbers, but I just rounded to the third.
I know, but I think it was negative 2.913. I think is what it should be. Did I mess up?
Negative 46x and negative 7x, I think you messed up there. You said negative 42x and.
Right here? This part?
Yes.
That should be negative 47x. Then if I move it over, that should be a positive 47x minus x. Should be 46x. That part looks good. Give me just a second. I've messed up somewhere probably. Negative 2x squared. That's a positive 5x squared. Negative 5x squared. Negative 140. Yep. That's where I messed up. 100%. This should not be negative 136. It should be negative 134. Because negative 140, that'd be 140 minus 6. It should be 134, not 136. That'll be your number. Little algebra error. Everybody's good there? It says, yesterday we looked at a particular rational function that represents the concentration of anesthesia in a patient's body. Today we're going to look at some other features of rational functions. So right here they've got a rational function. Notice it's in factored form. Right? And it's shown to the right. So A, what's the limit as x approaches infinity of g of x? So as the x's get really, really big, what do you think the limit's going to be? 1. We're approaching 1. Okay, it says complete the table of values. So what we want to do there is let's put this function in our graphing calculator. That will be a great way to find the table of values. So if I go y equals, let's see, I got a fraction. It should be x plus 5 times x minus 3 over x minus 3 times x plus 1. Okay, so to get a table of values, let's all go to second table set. We want to start our table, it looks like at negative 5. And let's just make delta table be by 1. So we're starting at negative 5, going up by 1s. Is everybody here? Can I go? Can I go? Can I go? Second graph to pull up a table of values. So now when x was negative 5, the y value is 0. I could kind of see that on the graph already. Right, with the picture that they gave. What about when x is negative 1? Okay. The calculator said error. That's cool. Yeah, it's going to be a domain error right there. We'll talk about why in a second. When x is 0, what's the y value? 5. That's the y-intercept. What about when x is 3? Error. Cool. And then when x was 4, we've got 9/5, which is 1.8. So now, looking at all of these things that happen in the domain, let's look back at our function. So think about in factored form, that was really good at like giving roots, right? Or where x is equal to different values. We don't have time. I don't have time. I'm sorry. We're gonna hurry. Okay. I don't hate her. If I look at, so this factored form, that's going to give me x at -5, right, if I solve that out. Well, what happened at -5? The y value was 0. So this gave the x-intercept, which again makes sense. It's in factored form, right? In factored form, it's good at finding roots. Yeah, we follow? So why did this not give an x-intercept? Because this would give 3, but 3 gave an error. You see my conundrum? You see what I'm... So this numerator gave the x-intercept, but this one didn't. Anybody think they could figure out why? Why? It should be. I agree, but why? That's what I'm asking.
The denominator has the same.
Because the denominator has the same factor in it. And what would happen if I plugged in 3? Because like, what we're doing is like right here, x-intercept was -5, which means if I plug in -5, I get out 0, right? What happens if I plug in 3 to this function? I plug in 3 down here. 3 minus 3 is 0. 0 times whatever is 0. And then I get a divide by 0 error, which is one of the things you're not allowed to do in math. Can't divide by 0. So the reason that this doesn't give an x-intercept is because it has a common factor in the numerator and the denominator. So because of that, we can think of canceling this out. If I have a common factor, that gives a hole in the graph. Okay, common factors give a hole in the graph. And you can see that hole right here. And that's why it spit out an error, right? There's only 2 ways I can get an error. Can't divide by 0, can't take the square root of a negative. There are no radicals here. So everything's divide by 0 error. So does anyone see another error that could happen in the denominator? What could I plug in that would break this part in the denominator? -1. And what happened at -1? Error. But why was there not a hole? You see, there's no hole at -1. What is there at -1? Vertical asymptote. So why did one denominator error cause a hole and one caused a vertical asymptote? In general, the denominator factors, they always give vertical asymptotes. With one exception. If the factor also exists in the numerator. So because this had a common factor, it becomes a hole. Because this didn't have a common factor, it's a vertical asymptote. So if you think about it, the numerator gives x-intercepts. The denominator gives vertical asymptotes. If there's a factor that's in both of them, it's a hole. Do you want me to say that again? You may want to write that. I don't know. Again, I'm not great at notes. You can see I'm a disaster. But it's all up here. The factors of the numerator give x-intercepts. The factors of the denominators give vertical asymptotes. But if there's any common factors in the numerator and denominator, it gives a hole in the graph. Can I look at 3? For what values of what values of x is g not defined? So what are the x's that break the function?
-1 and 3.
What is happening at the graph at x equals -1? Why do you think this is happening? You're getting a divide by 0 error, right? See, this is one of those things where these lessons are supposed to be, you are exploring it and learning it as you go, and I can't help but just ruin it and just, I don't like teaching that way. I'd rather give the information up front. So the rest of this page may be kind of repetitive for you because I've kind of already ruined the whole big surprises. Which that's good. That means you know it. All right, that's what we're hoping for. What about 5? As x gets closer and closer to -1 from the left, what is happening? So we need to look at the graph there. This is called a one-sided limit, is what they're working at. So looking at the graph, as x gets closer to -1 from the left, which means I'm over here. As I get closer to -1, what's happening to the values of g? They're going to what? Negative infinity. So we could say this. We could say the limit as x approaches -1. Watch this. Watch this. From the left. That's the limit as x approaches -1 from the left. It's a negative sign. Of g of x is negative infinity. Now what about as x gets closer to -1 from the right? So as we get closer to -1 from the right, we're going towards positive infinity. So I'll let you try to guess how you're going to write that limit. So this is a real big deal in calculus again. Because as we approach a number from two different sides, we have different, it approaches different things. As I approach from different sides, then that means that I can't take a derivative there as you get into calculus stuff. That one of the things that has to happen is the limit from both sides must go towards the same value to be able to take a derivative. Again, doesn't matter, but yes, but that's not going to happen much with, there's more stuff too. But that's really cool what you said, the limit has to go to the same thing. One thing that I've never really talked about with asymptotes before, that they really talk about in this A+, is called togetherness. So togetherness. So as we approach a vertical asymptote here, my graph does not have togetherness because it's going in opposite directions. But sometimes they will agree and both go up or both go down. So the togetherness at the vertical asymptotes is what we're going to be working towards later. 7. Describe what is happening on the graph at x equals 3. What happens? There's a hole. Why do you think this happens? There's a divide by 0 error. But same factor is in the numerator. So that's why it wasn't a vertical asymptote. That's what made it be a whole. Right? Because I could cancel that out. 8. As x gets closer and closer to 3 from the left, what is happening? So the limit as x approaches 3 from the left of g of x is, what are the y's getting closer to? As we approach 3 from the left. The y's are getting closer and closer to what value? 2. Now what about as we approach it from the right? The limit as x approaches 3 from the right of g of x. So as I get closer to 3 from the right, the y's are also going towards a y value of 2. That's where it agrees. Right? We're approaching the same value from either side. Try to check your understandings tonight.
Long division to divide the numerator by the denominator. The line y equals quotient is the oblique asymptote. Does the rational function intersect its oblique asymptote?
Okay, so this is the third case up there. The degree of the numerator is greater than the degree of the denominator. The degree of the numerator is 3. The degree of the denominator is 2. So we have an oblique asymptote at y equals, and then the answer to our long division question. So let's do a long division problem here, because we haven't done one of those yet. So the numerator, what's on top, goes inside. Reminder, just like with synthetic division, remember we need to go down in order of our exponents. So this is my x to the third degree term. The next term needs to be x to the second degree. Does it give me an x to the second degree? No, so I need a placeholder. Just like we do with synthetic. So 0x squared minus 3x to the first plus 2. That's going to be divided by, I'm going to have x squared plus 3x minus 10. You said you hadn't done long division? Just on Canvas, okay? So let's talk through it then. Think about when you divided in elementary school, right? You took the first thing out here and you wanted it to match the number inside here. So like for instance, if I did 3 divided by 9. 3 times what gives me 9? 3 times 3 is 9. Right? You want them to completely match. So same thing here. I've got an x squared. I want it to be x cubed. So x squared times what is x cubed? X. So x times x squared is x cubed. But we have to distribute it to everything. X times 3x is 3x squared. X times negative 10 is negative 10x. So this is the step I'm to. I'm here. Then what's the next thing that we did when we did division as a little kid? We subtracted. Why do we subtract? Because they told us to. Right? I mean. So guess what you need to do here? Subtract. Which means you're going to change the sign of every term. Subtract. So this becomes a negative x cubed, a negative 3x squared, and a positive 10x.
Why do you not do anything with the 2? Is it because it's a constant term?
Because I didn't have enough here to get to the 2. If it was longer, I would keep going to the 2. Now, x cubed minus x cubed is 0. if you do long division and that first term doesn't cancel, you messed up. That's the whole point. That's what you're trying to do, is make it match. So if it doesn't go away, you've done something wrong. Just know that. Okay. Now combine. 0x squared minus 3x squared is negative 3x squared. Negative 3x plus 10x is positive 7x, and we're going to bring down the positive 2. Now we keep going. I've got an x squared, and I want it to be negative 3x squared. X squared times what is negative 3x squared? Negative 3. So now then I need to distribute that negative 3 to everything. Negative 3 times x squared is negative 3x squared. Negative 3 times 3x is negative 9x. Negative 3 times negative 10 is positive 30. And then what do? We change every sign. Negative 3x squared plus 3x squared is 0. It cancels. If it doesn't do that, you messed up. That's the whole point. 7x plus 9x is 16x. 2 minus 30 is negative 28. Do I have anything left to bring down? No. Now then, we can try to divide again. I've got an x squared, and I want it to become 16x. So I'm going to have to go down in power. That's the time you can stop. Okay? Because if I go down in power, it's no longer going to be a polynomial answer. It's going to be a rational answer. So we stop here. So when you actually do long division, we would write the remainder as our numerator. And we would write what we were dividing by as the denominator in a real long division problem. We're not really doing long division here. Right? We're trying to find an oblique asymptote. So for us, the remainder is useless. But I'm just showing you because you acted like you've not seen a long division problem before. So forget the remainder part. All we care about is the real number part. And so I have an oblique asymptote at y equals x minus 3. So have we graphed this yet? I'm going to say no. Did we put this in the graph to look at it? Did I? I didn't remember doing that.
You did, because why you call it out to you? It looked weird.
I'll graph it again, just so we can see what we're looking at.
Yeah, I still got it.
So in my graphing calculator, I've got an x cubed minus 3x plus 2 over x squared plus 3x minus 10. And now that I'm going to also enter my oblique asymptote, which is y equals x minus 3. Now then, if I go to, I'm going to click zoom, zoom standard. So we're all looking at the same thing. So I can see here as x goes to positive infinity, we are tending towards the asymptote. Right, see how the blue line gets closer? But what about as x goes to negative infinity? Well, I don't see that, but I can zoom out. So zoom 3 is zoom out. Click enter. Now I see more of the graph. You see how we tend towards the asymptotes at the extreme values. If it does cross it, it's going to be somewhere around the vertical asymptotes. Okay, so to answer the second part of the question, it says, do they intersect? Well, let's do it on the graphing calculator first. We could go to intersect, and it looks like they cross right here. Right, so I could say, here's the blue curve, here's the red curve. They intersect somewhere in there, and it tells me it's at 1.75. Negative 1.25 is the intersection. Now, does it look like they intersect anywhere else that I can see? Here, the blue is beneath the red. It looks like forever. Here, the blue's above the red. It looks like forever. So that's graphically how we could check intersection. Yes. Okay. Anything else on the calculator part? Or can I disconnect this and put the iPad back up? Is everybody okay with that? All right. And then I'm coming back there. I showed you graphically how to tell where they intersect. Let's do it algebraically. So my original function was y equals, read it to me, x cubed
Minus 3x plus 2
over x squared.
plus 3x minus 10.
And now then, I'm wanting to check, where does this function intersect with, was it x minus 3?
Yes.
So I'm looking for where those y values are equal. So I can plug x minus 3 in for y here. Just algebraically, x minus 3 equals x cubed minus 3x plus 2 over x squared plus 3x minus 10. Hopefully they don't give you one like this without a calculator, because it'll take a little time. But they might, I have no idea. So if you do, fraction equals a fraction, and I'm going to cross multiply. So 1 times x cubed minus 3x squared plus 2 is x cubed minus 3x squared, 3x to the first plus 2 equals, and then we have to distribute here. This is why you don't foil. X times x squared is x cubed. X times 3x is positive 3x squared. X times negative 10 is negative 10x. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 3x is negative 9x. Negative 3 times negative 10 is positive 30. And now let's see, group-like terms. So x cubed and x cubed on each side, those cancel. I've got a 3x squared minus a 3x squared, those cancel. Okay, negative 10x minus 9x, those combine to give me negative 19x plus 30 over here. So then if I move that over, that's going to be positive 19x minus 3x is 16x. And if I move the 2 over, that's going to become negative. So it's 30 minus 2 is 28. These are the Mickey Mouse techniques, if you like. And so x equals 28 divided by 16. I hope I did it right. 16. I feel good about it. So that would be 1 point. And that would be 12 over 16, which is 3/4, which is 1.75.
So you could basically just.
Ethan knows that.
So here,
Just discovered a
once I know the x value, I have to plug it in to find the y value, which again would be very mean without a calculator. Very mean. So I would say they wouldn't do one like that without a calculator. But just to show you, just in case.